Welcome back. Today we will discuss little bit about data block. Why we should use this and how. To do this, we will go there, program block, add new block. Here we have to select data block, give a name of your data block, or you can make it as it is, no issue. But given the name, it is easy to find where your tag is declared. So I am giving a name as use of db. Second thing, you have to select the type, your db type. From here you can select global db, array db, and some instance db. Instance db use only for the function block. When you use the function block, you have to choose the instance db, and there is another db called the array db. This is also a global db. We will not discuss the array db. We will discuss during the discuss about the data types. Now we will discuss only the db, global db type. And here is the number of db. You can choose by your own number by clicking the manual, or you can leave it in automatic. It will choose the available number. And here you can also create the db for fields function. Okay, click and it will open. Now in db only you can declare the static variable. So I am now creating 2 or 3 tag, and tag called motor command, and this tag data type is bool. Now I am calling another tag is called speed set point, and that data type is integer. We can choose here different data types. Here almost 30-40 or more than that data type. Here we'll discuss about this data type later. Okay, before we go deep in this db block and some function of this db block declaration tag, I want to show you in function block C. In our user program, we can use several types of tag in several memory area. Tag qw0, this is a peripheral, that means it used in the this tag address qw0.0 is available in your PLC CPU. That means this tag analog output module is there. And if you go in rename tag, you see that tag is global output. That means you can use this tag in anywhere. Anywhere means organization block, function block, FB block, and data type is what? Another, this This is another type of tag, that is global output. This is not peripheral tag. This is a peripheral tag, that means IO module tag. And also you can use some address like this, M100.0 or M0.0, MW10, MW12, like this. Also you can use as a MD200, 204. This DB is called the memory tag, flag memory. If you go to rename this tag, you see that is a memory tag, and this is not output or input tag. This is a memory tag, and so you can program with this tag also. But why we should use the DB block tag? There is some feature that are not available in the memory flag memory, but available in DB. What are those tags? Those tags are called the retain tag or retain tag. See, if you go to PLC tag, it will open like this. The all tag you have declare in your all tag declare in your instruction, in your logic user program. See, those tags are declared in the PLC configuration, clock memory and system memory, and those tag 1, tag 2 use in the user program, those tag. Okay, so this tag has you cannot make it retain. You cannot make it retain, and you cannot give a initial value also. That means startup value. If your CPU goes to stop mode and make it run again, that time it will not take any initial value, or take it from 0. But if you use the DB block tag, you can declare the tag initial value. You can make the tag value, process value as a retain, So we'll check that. So I am going online. I'll see. Again, I'm downloading it. Okay, so in here, this tag, now I am downloading. So all value it's going from 0 value, that QW is 0. If I make it 1, it take the variable okay. Also, if I sense the variable value as a 200 and make 1, so it is goes 0. So if we make it 0, this value keep storing. This value, if you change here 220, see, this MW20 keep it as a store with the value 200. Same, this value, if we change this tag, say 0.0 storing value, and this tag IO tag is not a physical IO tag. If it is physical, it will show as a colon P, periphery. It is not periphery tag, it is also global tag, global input tag. Now what I want to say that this value will not store if you make your CPU turn off and turn it on. It will goes to 0. All the value goes to 0. It will not save. Okay, we are checking that. Again, see all the value here 0. Okay, we can see peripheral tag value. Peripheral tag value we cannot check here. This value we can see here, but peripheral value can see here. We have to check from here. This peripheral out, we have to go online. So both is 0. Okay, but in global DB we can use in the organization block, function block, function everywhere, and with the retain function with the initial value function. So let's see. We are going to use of DB block. Now we are using here start value as a 0 and the false, and this value as a 0. So if we go online, we see that process value is also 0. Now we are make it turn on 1. Now it's 1, and we are giving some value as a 100. Now its value also 0. If we make the PLC stop again and run it again, value also take it same 0. It is not restoring because this value also start value also 0. Now we are given the store value as a 10 and as a true. Okay, now we are downloading. Okay, now the process value is 0 and false. 0 and false. We are setting this value as a 120. Now process value is 120 and this one is true. Now if you turn off your CPU and make it run again, see it is taking the start value true and 10. This 120 is not here. Okay, no, so this value is not storing true. It just use the initial value. Now how the value can store and use again when your CPU turn off and on? You can do by using the retain function of DB block. So I am giving a retain function only this speed set point. Now compile and download again. Now reinitialize, run again. Okay, now I am changing the value as a 300. Okay, see the initial value is 100, 10, and process value is 100, 300, and this is also 0, also 0. 0 means Okay, its initial value is 0 and this is. Now if you turn off your CPU and turn it on, it will not yeah, it will not uh, give a value as a start value. Speed set point will be should be 300 because you use this speed set point declaration tag as a retain and this tag is non-retain, so this value will be 0, will be false because start value is 0. Now let's see. Yes, this value is false, but this value keeps intact as before. Okay, now second function is you can snapshot your process value and store it, and this is a good function. Sometimes you load the value without seeing the current value. If you add some tag here and reinitialize that time, and also you didn't may mark as a retain, that time your process value may change. So before you change anything in DB block, any declaration or any change in here, you should take a snapshot of your process value. So it will take a snapshot. Snapshot means it will take the current process value as an image and keep it in memory. So during you download or make the PLC stop, you can download the value from the snapshot to your process value or snapshot to your start value. You can do that, but if you use the flag memory, you cannot do the snapshot. You cannot do. You have to write one by one in your notebook. Now here copy snapshot to start value. You can click here, all the value snapshot value goes to start value. You can make it. Okay, or if you if you 300 200 now, if you want to change the snapshot value in your process value, you can download by this button. So all the snapshot value goes to your process value against the declaration tag. Also here I say that it's called the all values. All the snapshot value goes to start value or monitor process value, actual value. But if you select the function set point, you can choose which tag you want to copy to your actual value or start value. I am creating another tag like test set point function, and this tag also a integer. I am initialize and download it again. And say this process value is 0. Now I am changing this value to 220. Now your process value is 2. If you make a snapshot, your snapshot value 220, and here now if you select this function, only this test set point and change value here, because this 300, all the value is 300. You cannot change, you cannot notify notice any change. So 33. Okay, now process value is 33. Okay, download it again. Now taking again the snapshot, now your value is like this. Now you can use this function that only set point of your snapshot value goes to start value. See, only this snapshot value goes to here. This 33 is not copied to your start value, because I have select the function set point only this one. So this way you can use some function of your db declaration tag. This db block you can use in two access way. One is called the optimized access, another is called the standard access. Optimized access, this is the optimized access block type. Optimized access block has no address, tag address. Only optimized access. If you use the optimized data block, optimized access data block, the variable, your variable will be all. If you call this, it will use, no problem. But standard data block, it also use a address. So how we can see that it is standard block or optimized block, and how we can change? So select this db and right click and then properties. In attribute you can see the optimized block access. If you deselect it, your db block will be standard access, and that time you can see there is another column, it's called offset. In that offset you can see the tag address also. Now it is 3 dot. If you compile it, then you can see there you can see the tag address. In this data block, where this motor block is used, where is the address, you can see. What is the difference is optimized access and standard access? See, optimized in standard access, you can see that motor command address is 0.0 and speed set point is 2.0. So in between motor command and speed set point there is 2 byte. 2 byte means 16 bit. In this 16 bit, only 1 bit used for motor command 0.0. Other 15 bit from 0.1 to 1.7 not used. This is empty now. But speed set point it's taking from 2.0, and another integer value is 2 bytes. So 2 and 3, and second one is start from 4, because 3 already 3 used by 2 and 3, and here 4 and 5. Now if you use another bool binary tag, paste bool here and compile it again, see it's taken from the 6. So it's taking another new address. There are available 15 bit address there, but it is not taken. This is the problem, this is the loss actually. This is you are not optimize your data block, you are not optimize your memory. So normal use of your DB, you should use the optimize block. So if you choose the optimize access of your DB, that time if you declare a testable here, it will take the address from here 0.1. So you declare this testable here, but it's taking the data from here. And again, if you choose another testable here, it will take the data from there. So this one will be 0.1, another one will be 0.2. This way you can optimize your memory in your CPU. So I am going back to optimize access now. Okay, there is no start offset at this column here. Okay, that's all.